here we have an isosceles triangle. So again, we have a figure in the coordinate plane, and it's located inside the xy plane. I have that the vertex of the triangle is located at the origin. So the origin just means exactly where the x and y come together, which is really the point 0, 0. And that's something that you do need to know on the SAT. So quick refresher, if you didn't remember what the origin was, it's the point 0, 0, and it's right here. So I have that the vertex of the triangle is located here, and the end of one of the bases is located at -2, 7. I'm looking for then a possible location for the other end of the base. So here I'm going to need to know a little bit more about the shape than I had to know with the square. So an isosceles triangle is a triangle with two sides that are equal and two angles that are equal. And I call the angle that's not one of these two the vertex angle. So this is some other angle. And I call these two the base angles. These are the legs of my isosceles triangle. And then I finally got the base of my isosceles triangle also. So I know that one of the points at the end is going to be -2, 7. So do the x first, go over 1, 2. And then I go up 7. So I'll say that's about here. And then I'm looking for a location of the other end of the base. The important thing with isosceles triangles is that these side lengths are the same. Obviously, I don't know much about the angles, and on the SAT, I don't need to do any sort of trigonometry. So if you're thinking, oh, I'll take the sine of something and then figure out the other angles equal, that's not going to be the most efficient way to do anything on the SAT. So stay away from that. If you're not given angles, then you're not going to want to deal with them. Here, what's important is that length. And we can use the distance formula to figure out the length of this particular leg. And then we can figure out where the other base is going to be, or we can look approximately. So if one was here, we could have maybe one that's the same length over here, or we could have one over here. Basically anywhere that we could get the exact same length. So the length of this one is going to be the square root of -2 minus 0, because I do have 2 points, right? I have the origin and this one, and that's important to remember, plus 7 minus 0 squared. So basically I have the square root of 2 squared plus 7 squared, and I have to figure out one of these points that's going to give me another length that's that same amount. So 7 and 11 squared is not going to be equal to this. 4 and 7 is also not going to be equal. This one's going to give me the exact same thing because 4 minus 0 for this x part of it is going to be the same thing once it's squared as -4, 0. And neither of those are going to give me the same thing as 2 squared. 2 and 7, well. So this one's my answer. And I could also sort of figure it out from having drawn it. So this one should be the same, and it's going to give me the same angle when I actually look at it. But again, that's not a huge deal, and that's not really something I want to go off of. But it's something you can think about. And 7, -3 wouldn't have given me the same thing either. So this one I choose based on distances and what I knew about the figure. That's pretty much it for the coordinate plane though. So just keep in mind that you're dealing with x, y's. Keep your points straight if you're dealing with two different points, especially in your distance equation. With the midpoint equation, it's not really going to matter so much, but here it does matter. And then remember that your shapes are the same if you're given an isosceles somewhere else, if you're given an isosceles in the plane, and you should be able to deal with things in the coordinate plane just fine from there. So thank you again for tuning into Educator.com. I will see you in future SAT prep videos.